All right, today we are in Lesson 5, Part B, which is all on domain. Before we start, I want to review the 2 rules of algebra domain. So far we've talked about the fact that anytime you are given a function, you need to ask yourself, do I have this or do I have this? What are this and this? What are the 2 things you want to look out for whenever we're talking about algebraic domain? Denominators and square roots. So just as a quick review up here, okay, the first one has to do with denominator. What do we know about the denominator? Sorry? You can't have a 0. So let's say, for example, I have x times x minus 4. What would you tell me the restrictions on the domain are? Take a second. X minus 4. Okay, x cannot be 4 or 0. In a number line sense, that means that at 4 and 0, I have open or gaps in my solution, which leaves me with 3 specific intervals that I should write in interval notation. Okay, that's the result of that. Now, what happens when I have the second this? First is denominators. What's the other? What's the other algebraic consideration you're looking out for? Denominators or square roots, yes? We can expand that and say even roots, 4th root, 6th root, etc. So if I have something in here like 7x minus 5, what do I do with what's underneath the root symbol when it's an even index root? Jordan. The root cannot be negative by definition. This can't take on a negative value. So algebraically, I'm going to take 7x minus 5 and do what with it? Go ahead, keep going.
It is greater than or equal to 0.
Greater than or equal to 0. This is an example of a linear inequality. To solve this, we isolate x. We've also done examples where I had a quadratic inequality that in order to come up with the solution, you actually have to do a critical value line and check values. Okay? If I solve this, I get x is greater than or equal to 5/7, which then my interval restriction that I have here is much, much smaller. My restriction becomes going from 5/7 with a bracket to infinity. Okay? So those are the 2 considerations that we have. We are just going to now apply them to our arithmetic combinations. Now there are 2 rules, 2 separate rules. So if you want to pull out a highlighter, I'm going to bring them up in red down here. Okay. The domain of each arithmetic combination, so that's the adding, subtracting, multiplying, and dividing, is going to be the intersection or the and of the domain of one with the domain of the other. The exception to that, however, is when we create the division of f divided by g, which we already talked about these restrictions yesterday in our notes. Okay, so this is the part, if you're going to highlight, that's important, right here. It's the domain of f and the domain of g. You're looking for the overlap of those 2 separate domains. And the domain of the other. So if I move forward here, in your notes, do you have f plus g written down, correct? Do you have like a table format? So you have this written in there? Okay. Right next to it, we have to figure out the domain. So I need to take the domain of f, and I need to take the domain of g as intervals, and I need to then determine what is the overlap. So if I come over here, what is the domain of 4 minus x squared? How would I figure it out? Jordan.
Oh, wait a second. Set the thing of the square root greater than or equal to 0.
Greater than or equal to 0. This is another example of a quadratic inequality. X squared inequality. What does this factor into? What does it factor into? 2 minus x, 2 plus x, greater than or equal to 0. So on my number line, I've got two critical values, one at 2, one at -2, that are solid circles. Now notice this is not like denominators where I'm eliminating them. I'm actually stating that they are solutions. What number would you like to check? Give me a number. 3. If I plug a 3 in here, don't I get -1 times 5, which is -5? My signs will alternate. This negative matches this negative. And I'm looking for which region, positives or negatives, for greater than. Positives. So my domain for the left f function, and I say left because it's written here, is going to be between -2 and 2 with a bracket. Well, think about it. Out of all the numbers in the world on a number line, I've just taken that down to a very small set. It's still an infinite set, but it's much smaller in what it looks like compared to every number in the world. What about x plus 1? What's its domain? Do I have a square root? Do I have a denominator? No, so this domain is going to be -infinity to infinity. So I have every number in the world and this smaller one. What's the overlap of those two sets? What do they have in common? The overlap, the and, is going to be what? Yes? -2 to 2. Solution. Are there any questions on that answer as the overlap solution? If you were absent, it might be a little surprising right now. Yes?
When you factor the minus x, 2 plus x,
Mhm.
and then you put on the number line,
Yeah.
it's 2 positive 2, how do you get a
This?
-2? Yeah.
If I plug a -2 into here, what does it give me? 0. That's what I'm looking for. What gives me 0? Because I want to equal 0. The critical values are what equals 0 when I substitute them in. Okay? Other questions? All right, here's the great news. You're going to find as we work through these, f plus g, f minus g, f times g will always have the same domain. Why would that be? We'll take a look at this problem. If I move to f minus g, here's f, here's g. It's the domain of g. It's not the domain of like you're not changing the signs. You're going back to the originals. Have the originals changed at all in this problem? No. So, don't I have all of the same exact work? Yes. Okay, so for the next one, you can write the same answer. Adding, subtracting, and multiplying. Once you find one of those domains, they will be the same for all three because we are in no way changing f or g. Here's the next one, f times g. We're looking at the domain of f, the domain of g. Those are the same exact answers. The bump in the road is going to be the division, the arithmetic f divided by g. The f function has the same domain. The g function has the same domain. But what we have to take into consideration is the fact that, notice right here, what is x not allowed to be? X cannot be what? X cannot be -1. So yesterday when you asked, do I always have to write that? Well, you don't, but you still have to remember that that's true when I ask you to determine the domain. So now I have this scenario of this going from -2 to 2, but I have a break in the graph at -1, which generates 2 separate intervals from -2 to -1, union with -1 to 2 with a bracket. All right, questions on this, why it looks different or anything? Be very clear in what you're doing. You're looking at the overlap of the two functions and then eliminating anything that would violate the denominator that falls in that domain. If this was an x plus 10, it would not change my answer here because -10 is outside of what I've already said was the overlap. Questions? Good? Okay. All right, let's move on. Next up, composite functions. One of the reasons that I chose to move this to a second day, this all used to be one day of notes that we would just go all the way through, is because while it seems very small to you, there is a difference in rules when it comes to domain. Okay? Here's my example. All of you just watched number 81, correct?
Yep.
81 was a relationship between time relating to temperature relating to the number of bacteria. Yes? Okay. So when you found N of P of T, right? We explained in the video, or I explained rather, that this ends up coming up with a new function that relates time to number of bacteria, right? It takes out the middleman of temperature. Does that make sense? But there's a small little piece to that. And that's the fact that if ultimately we're talking about the inner function of temperature versus time, can I have negative time? No. So I have to think about the restrictions of what I'm starting with, like what the variable is representing, because that is going to affect the number of bacteria. So that makes us have a different rule. Let me show you what that rule is. The domain of a composite function is going to be, and I'll highlight this in green down here, it's the domain of what we're going to call the inner function, or the ingredient, and it's the domain of the new function that you get after you plug in the inner function. You have to look at those two and say, what's the domain of this, what's the domain of that, and then find the intersection of the two. The rule is different. Everybody tells me, oh, I'll just go to the new one. No, you have to think about the old one first, the one that you're plugging in. Okay, so the domain of a composite function is find the domain of the inner starting function, and then give me the domain of the new, and tell me the intersection of the two. All right, so we did this in your notes yesterday, correct? F made up of the g function, so we got x minus 16, yes? X minus 16. So following my rule at the bottom, I have to start with the inner function, g of x. This is my inner. So I go to the g function. What's the domain of the inner function? How would I find it? The domain of the inner function here. Do I have a square root? Do I have a denominator? Square root. So what am I going to write as my inequality? Okay, so I've restricted my inner domain to 0 to infinity. All the numbers in the world just got restricted to 0 to infinity. Now, that's the domain of 0 to infinity. And what's the domain of my new function, x minus 16? What's that domain? Negative infinity to infinity? All right, so this one's going to be negative infinity to infinity. So what's the overlap of those two? 0 to infinity. If you are literal with this and it says f of g and you just tell me the domain of this, it will be wrong because you never considered what you were starting with to put into the function. Yes? Questions? Anything that's rolling around your brain? Yes.
So the final answer to the domain would be that.
Be that one. Okay, let's do this. Let me ask you a question to kind of turn it around. What do you think it should be? What does your brain tell you it should be?
I don't know. I'm just being thrown off by the negative infinity.
Okay. This part here? All right. So is it the fact that you can't see the overlap? Or is it the fact that literally this says, what's the domain of this, and you just want to tell me the domain of the green? Is it the fact you feel like you should just focus on this, or is it that you can't see that the overlap of the purple and the red is this green down here? It's this here. Okay. So, you know the example that I wrote up here about temperature versus going down to bacteria? Ultimately, the number of bacteria you have relates to temperature. Relates to time, not temperature. Yes? You're with me? So if it relates to temperature, there are restrictions on temperature, right? For whatever environment you're in, there's only so many highs and lows that the temperature can be. That's an example where we have to consider from the beginning the restriction on domain of temperature. That idea, carry it into here. Go to g of x. Instead of temperature, we're going to look here. This restricts what I can plug in right from the beginning to 0 to infinity. Yes, my new function looks like you can use anything in the world, but you can't because you have to consider what you were starting with. That's where I've got this new definition coming in. Good? Good. All right, last piece here. G of f. So now, I'm going to erase this. This is going to look even different. My f function is going into there, so my resulting was the square root of x squared minus 16, which we said we can't break down. We can't simplify any further than that, yes? So now I want to find the domain of that. Take a look. What would be considered my inner function here? Which one, g or f, is the ingredient? F is the ingredient now. And what is my new function? X squared minus 16 underneath the root. So let's start here. The domain of f of x. So I go to f of x. Do I have any square roots? Do I have any denominators? No. So what's my domain? Negative infinity to infinity. And what's the domain of my new function? How do I figure out what the domain of the new function is? Yep. X squared minus 16 is greater than or equal to 0. What type of inequality is this? Quadratic. You cannot isolate x. You have to factor, set up a critical value line, 4 and negative 4 with solid circles. Now, for the benefit of everyone, to this point, does anyone have a question how I got the critical value line or the two numbers of negative 4 and 4? What number would you like to check? 5? If I plug a 5 in, I'm going to get a 1, and I'm going to get a 9, which is positive 9, plus, minus, plus. And I'm looking for what regions? Pluses or minuses? Pluses. Here and here. So that's going to be negative infinity to negative 4, union with negative 4 to infinity. Okay, every number in the world, restricted domain in green. Put the overlap together. What's the answer? Yes.
But where are you putting in 5?
Right here. What is 5 minus 4? 5 plus 4. What's the product of those? Positive 9. Is positive 9 greater than or equal to 0? Yes, it's a positive because these signs match. Okay, so I have the blue, I have the green. I'm going to look for the overlap. Final answer. negative infinity to negative 4, union with negative 4, not negative 4, this should be a positive 4, to infinity. This is a negative 4, this is a positive 4. Typo. Yes.
So the sides will always alternate?
Good question. Will they always alternate?
Yes.
The answer is actually no, but I'm not going to give you one that tricky. The reason that they would not alternate would be if, when you look at your parenthesis groups, if you had a repeated factor. If you had a repeated factor, it was a double root, so the sign stays the same on either side of those. We haven't done any like that. I wouldn't give you one like that. Questions, concerns?